especially this time of day. Maybe you've already eaten. So you start to get that lull to fall asleep. All right, so we're going to continue on with lipid biosynthesis, but now we're going to talk about what happens if we need to do complex fatty acids. So not just up to 16 carbon single bonds. Oops, let me switch these out so I don't miss anything. Hopefully you can see that. I can see it on mine. Yeah, it comes up. So the building block here is palmitate. That's the common name. It's palmitate. Okay, so the elongation process for fatty acids occurs primarily in the smooth ER. Some can occur in the mitochondria, but the primary location is going to be in the smooth ER. So it's another, degree of compartmentalization, groovy, that kind of thing. All is good. And so when I say elongation, now we're talking about what happens if you need to make something that's got even more than 16 carbons. Desaturation, which is just the fancy way of saying that you're making double bonds. Remember, a saturated fat means it's all carbon, hydrogen, all single bonds. So an unsaturated fat is one that's going to have at least one double bond between two carbons. Polyunsaturated means there's multiple double bonds. We're going to talk about that. It's a little bit more tricky than what you would just expect, but it usually primarily occurs, it's in the ER.
Is this smooth ER as well, or just kind of?
I don't remember ER. That's good for me, ER.
Okay.
So this is a problem for us. Because we're mammals, believe it or not. Okay? But our hepatocytes, that's the fancy term for liver cells, they can make double bonds easily, in the ER, all the way up through carbons 9 and 10, but we can't go beyond that position. It's like too far away. We can only do it in carbons 9 and 10. That's a problem because some of our really important polyunsaturated fatty acids, those PUFAs, those healthy ones, they have like double bonds at carbon 15 or carbon 18. They have double bonds much further beyond that. And so we have to have some of our fatty acids from plant materials. Okay, and those are called your essential fatty acids. So we can make some simple unsaturated fats, but we can't make the ones that are too big. And so one of the downfalls for someone who doesn't get enough plant-based foods in their diet, if you're not getting enough, so make sure that you have some type of supplement otherwise, because if you're just eating beef, then you're not going to get that supplement because cows can't do it either. Don't take that as being some type of political statement that you can't eat beef. I don't want to be sued by the state of Texas, Like, I don't know, it's probably before, you guys probably were too young to remember, but when Oprah Winfrey got sued, by the cattle farmers in Texas and had to go to federal court because she had a segment and they said that it disparaged the eating of beef. It's been a long time ago, back when she had her show. Wow. She won, by the way. I mean, this is kind of ridiculous. But, we raised beef. We slaughtered cows. But you do still need to eat some plants. Okay. Well-rounded diet. So how does the saturation of fatty acids occur? I love the name of this enzyme. It tells you exactly what it does. Okay. Fatty acyl just means, once again, it's promiscuous. It can accept anything up through, carbons 9 and 10. Acyl-CoA desaturates. It literally means it's going to desaturate a fatty acid. Okay. So this is just the example. We go from something that has all carbon and hydrogens to a double bond. Something that's got a double bond. But it does it in a chain process. So ultimately, the electrons are coming from NADPH, but it's not direct. Okay, and so this is a new term that you may have actually heard of, because I mean, obviously these are important in vivo, but it's called a mixed function oxidase, and we haven't really talked about this. But what that means is that there are two different substrates, two or more, but there's at least two different substrates that have to get oxidized at the same time. Okay, and at the same time through the entire process. So how does that happen? I'm just going to call it fatty acid. So we have the reduced fatty acid that gets oxidized. So that means it loses electrons. The electrons get passed off here to process. Reduction, oxidized. Yes, I said that right. He's passed off here to a cytochrome B5. It's not so important to me that you know that this one's called B5, but it's to a cytochrome. That cytochrome then has to be regenerated, and it's regenerated by another enzyme activity called the cytochrome B5 reductase. That reductase utilizes FADH2. Okay, FADH2, which you've got to get the FADH2 back, and it's what takes the electrons from NADPH to make NADP+. And so that's why during this entire process, we are actually oxidizing both the fatty acid and NADPH. It's just through this string of enzymatic activities. So that's what's called a mixed function. We're going to talk about oxidases and oxygenases in greater detail. I don't know if it's this chapter or if it's the next chapter. All right. I like this next little figure in your book. It just shows you, it's a good review from last semester when we talked about the nomenclature that's used for fatty acids. And it shows you the importance of your fats. So this is palmitate. Does anyone remember, what does that 16:0 mean? 16 tells you how many carbons, and that 0 means no double bonds. Well, then and I will never ask you to memorize all their common names, please, no. I want you to know what this means. I had to memorize all of those common names and everything, palmitate and stearate and oleate and blah, blah, blah. You look it up now. Palmitate's the only one that you probably need to know the name of, because it's the one that's the building block. But see, we can desaturate it through the desaturase and make what's called palmitate. That one. That. Palmitate. That. Okay, which is 16:1 delta 9, and that just indicates, well, we already said that's the double bond, and what does the delta 9 mean? Where it occurs. So that means it's occurring between carbons 9 and 10, okay? Or we can elongate it in the smoothie R to make stearate, which is 18O, and do elongation to make even bigger things, but they all have to be saturated. Or another possibility is to make oleate, which is a stearate, but it's got that double bond in position 1. But this is where we have problems. Only in plants can they go on to make linoleate, okay? And they go on to make linolenate, which is has double bonds at 9, 12, and 15. So, the importance of these shaded boxes, anyone want to hypothesize, what is the importance of those shaded boxes? Why are those? Those are what?
Something like cleanse can do?
Yes, those are our essential fats. We have to have those in our diet since we can't make those 12 and 15 bonds. Now, during the process for us, during the process of desaturation, if you notice, like linolenate is easy. You can see that we edit at 6, but then we can elongate it from there, and it's at 8, 11, and 14, and so on and so forth. Okay, from the elongation process, but we can't introduce a new one beyond position 9. So this is really important that you get these in either from your diet, from eating plants and seeds and things like that, or from a supplement. Okay. This is also important because we get, is this one right down here? This is arachidonic acid, which whenever it's lost its hydrogen is called arachidonate, which is 20:4. And I mentioned this last semester, but I wanted to review it again. This is the building block and what we use in order to make the eicosanoids. A whole class of compounds called eicosanoids. They're made up of prostaglandins and thromboxanes are types of eicosanoids. So what are some of the functions of prostaglandins and thromboxanes? First of all, I always like to do the review. Why are they called prostaglandins? Because it had to do with the prostate. Do women have prostates? No. Do women have prostaglandins? Yes. So the history is they were first discovered in, there's a high concentration of sheep prostate, so they don't need prostaglandins if I was sex specific, and then the name stuck. So even though women don't have prostates, they have prostaglandins.
Did you just assume my gender?
What?
Did you just assume my gender? It's a joke.
Yes. Yes, I did. Which, by the way, that's actually good. Let me pause this. But yes, I did. So what are some of the functions that are associated with prostaglandins and thromboxanes? I mean, there's lots of different ones. What's one of the functions? One of the more common eicosanoids. Like, what's one problem you have whenever you get too many of them? Some of you may be experiencing it right now. No, stress can actually increase some of them. Well, yeah, that could be it. But I was thinking headaches, right? Headaches, which is due to, what's one of the causes of headaches? Well, I mean, but no, inflammation. A lot of the inflammatory processes that naturally occur, things like that. It also has to do with vasodilation, some of them do. But and we'll talk about the reasons why I wanted to specifically point out headaches. But inflammation of the blood vessels, well, that has to do with prostaglandins and thromboxanes and eicosanoids. Okay, and so we'll pick up with this on